Hi, this is the first of several videos in a second unit on high school chemistry. The first set of videos had to do with introductory matters. This now, second unit, has to do with some of the basics of matter and energy. So we want to start off by talking just a little bit about energy and chemical reactions. What is energy? So you might say, wow, he has so much energy in these videos. Or maybe you say, man, he's so boring in these videos. I mean, we kind of know what energy is. My lips are moving. You know, that's energy. Energy is, though, basically, we might say, the capacity to do work. And by defining it this way, it's interesting. We can actually say that when you hold a rock up in the air, that it has potential energy. It's not an energy that's being expressed. I mean, it's not doing anything. It's just kind of sitting there. It's a rock. But if I let go of it, all of a sudden, it starts to move. And so potential energy is, in a sense, a capacity to do work as well. Of course, the kind of energy we're more acquainted with is like kinetic energy, the energy of motion. My lips are moving. That's a kinetic energy. After I'm done with this video, maybe I'm going to go for a run. That will be kinetic energy. It may be slow, but it's going to be some kinetic energy. There's energy in heat, thermal energy. There's energy in electricity, and so forth. So just grab, there's different kinds of energy, but they all have in common this capacity to do work. Now, whenever there's a change in matter, energy is involved. Let's go back to something we talked about in the first set of introductory videos, physical and chemical properties. So, remember that a physical property has to do with what matter is doing when it's just sitting around doing nothing. So, this thing here is solid. It's not doing anything, but it has the property of being solid. It has mass, it has volume, it takes up space. It has a certain density. Those are not chemical properties, but physical properties. Now, chemical properties have to do with the capacity of matter to interact with other matter, and also what happens when certain kinds of matter absorb energy. When you have light on something, what's happening. Chemical properties have to do with properties that involve the change from one kind of matter to another. Interaction of matter and the absorption of energy. This is all in a previous video. So, changes in physical state are surprisingly physical changes, like boiling water. It changes state from liquid to gas. Changes involving chemical properties, like putting electricity in water and breaking it apart into hydrogen and oxygen. That's a chemical change. By the way, please don't do that at home. You might shock yourself. Okay, so exchanges of energy. All physical and chemical changes involve a change in energy. So energy is always exchanged or involved in a physical or chemical change. When water evaporates, maybe you put a pot on the stove with water in it. You want to make some macaroni and cheese. You start boiling the water. The heat in the plate is putting energy into the water, and the atoms are getting all excited. Man, this energy, a lot of heat, getting excited, and they begin to move more, get more kinetic energy. And they begin to expand, and eventually they pop out of the surface into the air as gas molecules of water. It's still water. It hasn't undergone a chemical change. It hasn't changed its formula. It's still H2O, but it has changed its state. And so all physical changes involve energy in some sense or another. Now, there are two different ways this exchange of energy can go. So endothermic processes are when matter absorbs energy, and exothermic processes are when matter gives off energy. The endo-exo, I don't know whether you know those two prefixes, but like a lobster has an exoskeleton. Its skeleton is on the outside, and you have to kind of pry the meat out from the middle. I have an endoskeleton. My skeleton's in the middle of my body. So endo within, exo giving out, thermo, heat. So endothermic, absorbing energy, exothermic, giving off energy. Now, the total energy is the same, both before and after this exchange of energy. This is called the law of conservation of energy. Matter can neither be created nor destroyed, and so also energy cannot be created or destroyed. The total amount of energy before is going to equal the total amount of energy after, and this can be a very useful thing to know. So this has been a taste of the kind of changes that happen when energy is involved in a reaction, whether it's a physical reaction or a chemical reaction.